All right, welcome to Lecture 8. Today we're going to be talking about beauty and attractiveness. And first of all, we know that beauty is something that men emphasize in their mating preferences more than women. Not that beauty isn't important at all to women, obviously it is, but it's more so to men, and this seems to be a universal pattern revealed by David Buss's international study. And on this slide we have data from 5 countries, including the United States, showing that men tend to rate this as being more important than women do. So what underlies beauty? Well, first of all, we need to keep in mind that physical attractiveness is, at least to some extent, determined by any indications of a person's health and also indications of their youth, right? Especially, youth is especially important to women because of the fast drop in reproductive value and fertility that happens as they age. So any indications of youthfulness or health on the part of a woman are linked to her physical attractiveness. But in the first part of today's lecture, we're going to focus on the waist to hip ratio, right? Which is a way of looking at how fat is distributed on the body. And the way that it's measured is by the size of the waist at the narrowest point, and you divide that by the size of the hips at the broadest point. Okay, and dividing one by the other will give you a percentage. So let's start with why this might be different for men and women. Right? We know that before puberty, male and female bodies look very similar. Right? But once puberty hits, male and female bodies start to look very different, and it has to do with the way that fat is distributed on their bodies, at least partly. And this is because of the way that testosterone and estrogen act on the body to distribute fat. Right? Testosterone causes body fat to be distributed mostly in the abdominal region, and testosterone actually inhibits the distribution of fat on the hips, buttocks, and thighs. Estrogen has the opposite effect. Estrogen tends to inhibit body fat on the belly, and it promotes the distribution of fat on the hips, buttocks, and thighs. And there's a healthy range for men and for women. The healthy range for women is from about 0.67 to about 0.8, while for men the healthy range is higher, right? Doesn't overlap. It's between 0.85 and 0.95. There's also studies linking waist to hip ratio to fertility. Women who are trying to get pregnant, so married women who are trying to get pregnant, those that have higher waist to hip ratios tend to have a harder time getting pregnant compared to those with a smaller waist to hip ratio. And studies done in fertility clinics show something similar, where women that have a higher waist to hip ratio seem to have less success. They also take longer, even if they are successful at getting pregnant, compared to women with lower waist to hip ratios. And this, the waist to hip ratio is also important for the neural development of children, right? So Lasik and Gowland have argued that fat deposits below the waist affect positively the supply of fatty acids that are used during neurodevelopment. Right, so body fat below the waist is linked positively to these fatty acids, while upper body fat seems to have a negative effect on the supply of these fatty acids. And in their study, they actually show a link between the waist to hip ratio of a mother and the cognitive development of her children. So it's a really interesting study. Now, waist to hip ratio is also linked with health. We know that the risk of getting certain diseases like diabetes, heart attack, and stroke vary mainly not with the overall amount of fat, but with where it's distributed, right? Specifically, fat on the belly is linked with higher risk for heart attacks than carrying fat from the waist down. So, in other words, or to summarize, there is a link between waist to hip ratio and fertility, and the development of children, cognitive development of children, but there's also a link with health. So given these things, it would not be surprising if evolution had shaped men's preferences in the direction of preferring women with smaller waist-to-hip ratios. After all, the waist-to-hip ratio is a cue that's easily perceived, right? You can see a small waist-to-hip ratio from many different angles and from a distance as well. Now, one of the first people to study the waist-to-hip ratio and attractiveness is Devendra Singh, and in his first paper he has two studies. I'll begin with the first. In this one, he examined the measurements of Playboy centerfolds from 1955 to 1990, and also the measurements of the Miss America winners, not just the contestants, but the actual winners from 1923 to 1987. And for these, in addition to calculating their waist-to-hip ratio, he also calculated their percent of ideal body weight. Right? He wanted to know whether these women were underweight, overweight, or at the ideal weight for their height. And he did this because of a concern that these women, who are supposedly examples of beauty, have actually gotten skinnier and thinner over the years. So he wanted to test that as well. And he found a slight drop in percent ideal body weight, right? So these women did get thinner over time, but he also found their waist-to-hip ratio actually remained fairly constant and stayed within the normal range for these two groups, right? Between 0.68 and 0.72. And on the left, we have the data for the Miss America winners. On the right, the Playboy centerfolds. So top left is the percent ideal body weight for the Miss America winners, and we can see that it actually went down over time. But in the bottom figure, we can see that their waist-to-hip ratio was pretty consistent, right? Consistently small over the same time, right? So although weight decreased, their waist-to-hip ratio remained fairly constant. And a similar pattern was found for the Playboy centerfolds. Although yes, their percent ideal body weight did get smaller, their waist-to-hip ratio still remained fairly small as well, showing that although preference for overall weight fluctuates over time, waist-to-hip ratio seems to be something that's consistently valued over time. But the first study just looked at these population of women without actually manipulating their waist-to-hip ratio. Right, so we don't know whether these women were viewed as attractive because of their small waist-to-hip ratios. So to this end, Singh carried out another experiment. This one manipulated the waist-to-hip ratio and body weight in drawings, right? So there was 12 drawings of a female figure that varied in waist-to-hip ratio and also in body weight. So the drawings were made to represent a woman who's about 5'5", who's either ideal body weight, underweight, or overweight. And within each of these three weight categories, Singh manipulated the waist-to-hip ratio. And in this study, at least, he had American men rank these drawings for their attractiveness from the most to the least. And in other studies, he used samples from around the world. So here we have the drawings that he used. We have the three weight categories: underweight, ideal weight, and overweight. And for each of these, we have a waist-to-hip ratio ranging from 0.7 all the way up to 1.0. And what he found is a main effect of waist-to-hip ratio, so that across each of the three weight categories, the smallest waist-to-hip ratio was the one that received the highest ratings. He also found an effect of overall weight, right? The ideal weight group tended to be ranked higher than the underweight and the overweight. So why is that? Why did weight have an effect in addition to waist-to-hip ratio? The reason is because weight affects fertility. It affects health, but it also affects fertility, right? So women can be have their fertility affected negatively by either being overweight or underweight, right? When women weigh too little, right, their body interprets this as a sign of famine, and it actually inhibits ovulation. Why? Because it's not a good time to have an offspring. There was also an interaction between body weight and waist-to-hip ratio, so that the drawing that received the highest ratings was the ideal weight with the smallest waist-to-hip ratio. And as I said, this Singh has used these kinds of drawings in different places and found similar patterns, right? Although the preference for body weight fluctuates, what is pretty consistent around the world is a preference for small waist-to-hip ratios. Now I'd like to tell you about another study regarding the waist-to-hip ratio. And this one examines whether it is predominantly a visual phenomenon. Right, so is visual input required to trigger this preference for small waist-to-hip ratios? So many psychologists have argued that it is, that it's our exposure to Western media, visual media, that tells us to value small waist-to-hip ratios. And if this is true, if we had to have exposure to magazines and other visual images to trigger this preference, we wouldn't expect congenitally blind men to have a preference for small waist-to-hip ratios. So this is what Karamans and colleagues actually studied. So the study compared congenitally blind men, normally sighted men, and sighted men who are blindfolded for their preferences for small waist-to-hip ratios. And the study was done in the Netherlands. And it's kind of a weird way to conduct a study, but basically the stimuli were driven to blind men's houses in a van. And then the blind men were asked to go into the van, where they were presented with two mannequins that had adjustable measurements. So one was adjusted to have a measurement of a waist-to-hip ratio of 0.7, and the other a waist-to-hip ratio of 0.84. And the men had to choose which one they prefer, and they had to rank them for attractiveness, right? So they had to rate each one on a scale from 1 to 10 for their attractiveness. Now, to get the rest of the participants, they took their van to a shopping mall, and they asked the sighted men to look and rate them for their attractiveness, and they also blindfolded some of these men and told them to use their sense of touch to determine which is the most attractive mannequin and to rate their attractiveness on a scale from 1 to 10. And these were the results. So we have the three categories, right? The three groups of men: the blind, the sighted, and the blindfolded. And we have how they rated the attractiveness of the mannequin with the 0.7 and the mannequin with the 0.8 waist-to-hip ratio. And what we can see is that for each of these three categories of men, they rated the smaller waist-to-hip ratio more attractive. Right? So blind men also prefer small waist-to-hip ratios. This shows that visual input isn't necessary for the development of this preference. But if you go back to the figure, we can see that the preference was enhanced for the sighted men, especially the men who weren't blindfolded. So what Karamans and colleagues conclude is that the visual input, although not necessary to create this preference for small waist-to-hip ratios, it can enhance and fine-tune this preference and make it more magnified. All right, so let's turn away from bodily beauty and look at facial beauty and the factors that underlie it. The first thing I want to start off with is that the ability to discriminate the attractiveness of faces appears very early on, right? So the conclusion here is that even young infants, even a few months old, they prefer to look at the faces of attractive people than less attractive. And one of the first studies looking at this was by Langlois and colleagues, right? So they had 6-month-old infants as participants, and they showed them so they're laying in their crib, and they show them on a screen above them two faces that vary in attractiveness, and they record how long, which one they look at, right? So which one they look at, and how long do they spend looking at each face. The idea being that if they find it more attractive, they'll spend more time looking at it. So these faces, as I said, one was more attractive than the other, and it was adults that pre-rated the faces for their attractiveness. Okay, so they recorded which slide the infants looked at and for how long. And there's 3 experiments here. In the first experiment, the faces that the infants saw were the faces of white men and women. So for each pair, the sex was the same, right? So all that varied was attractiveness. And the infants were all white, 6-month-old infants, or mostly white. In experiment 2, the participants were 6-month-olds, and in this one, so these white infants were shown pairs of female faces that were African American, also varying in attractiveness. And they did this to see if the effects of attractiveness would span across a different race, or whether it held only within a particular race. In the third experiment, right, the infants actually saw, rather than seeing the pictures of adults, right, slides of adults, they saw slides of 3-month-old infants, right, that also varied in their attractiveness, right, male babies and female babies. So what do they find? So we have here the means for the faces that are highly attractive and the less attractive, and we have how much time in seconds the infants spent looking at each picture. Right? And what we can see is that for each of the 3 studies, the 6-month-old babies prefer to look at the more attractive face. Right? They spent more time looking at the more attractive face. Right? Even if they were from a different race than their own. Right, so what this tells us, and similar studies have been done with infants who are even younger than 6 months, and what this tells us is that standards of beauty don't have to all be learned through enculturation, right? The assumption in psychology and anthropology has been that standards of beauty require long periods of enculturation, that initially infants don't see beauty at all, but this is something that they learn, and while all of that may be partly true, it's certainly not the complete story. But again, this doesn't tell us what makes some faces more attractive than others, right? So what makes a face beautiful? And here there's been a lot of research done as well, looking at the effects of different features. One important feature seems to be bilateral symmetry, whether one half of the face is a mirror image of the other half of the face. Why would symmetry be important in beauty? Well, for one, it's correlated with health, right? Especially during development. If during development a body is exposed to toxins, to disease, it tends to affect the symmetry of the body. Why? Because it takes a lot of energy, it takes a lot of resources to produce a symmetrical body. So a disease can affect the symmetry of the resulting body. So that means if you're looking at an adult, if their body is symmetrical, it means that they have a robust health, right? And they have the ability to withstand environmental stressors, including diseases, fluctuating nutrition, and so on. Okay, so it is a sign of health. So here's an example of symmetry. On the left, we have a normal face, right? And you can see that it's asymmetrical, right? The left and the right don't appear to be identical. The figure on the right, which is created by, doubling one side of the face, is more symmetrical. And in general, symmetry is related to beauty. And I've seen studies looking at movie stars, for example. So movie stars that people tend to view as being very attractive. I've seen, for example, like Tom Cruise, for example. His face is very symmetrical. So looking at different parts of the face, a higher than average degree of bilateral symmetry. But again, symmetry can't be the whole story. There's probably much more to beauty than simply symmetry. Which brings us to another feature that determines the attractiveness of a face, and that's averageness. Averageness here doesn't mean average attractiveness, but it has to do with whether the features, right, the facial features and the way that they're arranged on the face correspond to the mean of the population. Right, so think about, for example, distance between the eyes. Some eyes are too far apart, some eyes are too close together, and some are just right. Well, which ones are just right? The ones that correspond to the average distance between the eyes in the population for either male faces or female faces. Same with distance between the lips and the nose, right? There's an average distance there in the population, and if a person has that, then that feature is attractive. So what evidence is there that averageness plays a role in attractiveness? Well, there's been studies done with what are called composite pictures. And the way that these work is that you take, so if you're looking at female faces, for example, if you take individual female faces and pictures of female faces, and you remove the hair from those pictures, and then you average out all those pictures, the result is a composite. And the composites tend to be rated more attractive than the individual faces that make them up. And this makes sense if beauty equals averageness. Why? Because the composites should have features that correspond more to the mean of the population than any of the individual faces that went into creating them. And the other feature is that, the other fact is that the more faces that go into creating the composite, the more attractive the result. Okay, so here's a very simple illustration of averageness. The middle and the right pictures are actual people, and the face on the left is a composite created by averaging the features of those two participants. And most people would agree that the face on the left is more attractive than the two faces on the right. And that's just with two faces. So can you imagine if you combine like 12 or 20 or 30 pictures, right? The result would be even more attractive. But again, there's more to beauty than mere averageness. Right? One of the things that we see is that the composites that you get from combining these individual faces tend to be kind of generic looking. Right? But true beauty seems to be anything but generic, right? And the women and men that the people tend to rate as most attractive don't tend to be generic looking at all, right? So this raises the possibility that true beauty requires exaggerating certain features. And this is something that Victor Johnston has studied. Right? He showed that hyper-feminized faces are more attractive than average faces, and hyper-masculine faces tend to be more attractive than average faces. So the way that you hyper-feminize a face or hyper-masculinize a face is that you look at those features of a face that distinguish male faces from female faces. and you exaggerate those. So for example, female faces tend to have bigger eyes than male faces. So if you make a female face have bigger eyes, the result should be a hyperfeminized face, and it should be more attractive. Females also tend to have narrower noses than men. So if you exaggerate that feature, maybe it'll make it more attractive. Women also tend to have narrower jaws. So if you make it even narrower than average, you may enhance its attractiveness. So why would this be a factor? According to Johnston, hyperfeminized features, right? Features that exaggerate those feminine characteristics are signs of high estrogen. And high estrogen is a sign of high fertility. And it's also a sign of low testosterone, right? So it really is an indication of the low impact of testosterone and high impact of estrogen on a face. And we have this example here, right? On the left, we have a composite face made up of actually 16 faces being morphed together. And you can see the one on the left is attractive, but it's kind of plain looking at the same time, kind of generic looking. So what Johnston did is he feminized that face by making the eyes a little larger, the nose a little narrower, the lips a little fuller, and the jawline a little narrower, and he created the figure on the right. And most people would say that the figure on the right is more attractive than the one on the left. Okay. And we get something similar with male faces. The male on the left is a averaged male face, kind of generic looking, but then you make the eyebrows a little bigger, the nose a little bigger, the jaw a little fuller, and you get the masculinized face on the right, and most people would rate the one on the right to be more attractive. Now, there is interesting research coming out of Victor Johnston's lab which shows that females' preferences for male features tends to depend on their monthly cycle. All right, so where they are in their cycle. So let me explain. So they start off with a face like the face in the middle, and the face can become gradually more masculine, and women are asked to rate, to stop it when it becomes the most attractive male face. And they did this, and then to have some kind of measure of retest reliability, they had women come back and do it again. And they found that sometimes they preferred a man who's on the more masculine end than at other times. And they wondered why that would be the case, and they figured out that it has to do with ovulation. Right? So when women are at greater risk for becoming pregnant, right, they tend to prefer a more masculine man. The rest of the time, they tend to prefer a man with softer features, less masculine. All right, so that I find that to be a very interesting finding. We'll talk more about that later.